So you guys received this document Sunday night, I believe. Is that right? Sunday night? Maybe. It's in your Canvas message. All right? And just so you guys know, I don't just send silly things. I make sure that when I send things, it means something. So if you see a Canvas message from me, it's probably important. Okay? Hopefully there's no bagel stuck in my teeth. I'm sure there is. But anyways, this was sent to you. And in the message, a couple of things. Number one, first thing is this. For some reason, I allowed lab work 1 to be due on Saturday at 6 p.m. Why? I have no idea. But maybe it's because it was first week, I was like, I'll give them a little extra time. Just so you know, that's a mistake. It's never going to happen. All of your lab works from here on out will be due Friday at 6 p.m. Although I did get a message saying, I'm not sure why I can't get into the lab work because I can't submit it. It's only 10 p.m. I'm not late. So I had to remind them, actually, no, it's 6 p.m. So yes, you are late. That's why it's closed. That's why you can't get into it. Okay? But anyways, so I was sending this out because this is a dry run. And yes, your lab work 1 is going to get excused anyways, so it doesn't really hurt. This is a dry run. So I did the 4 problems that, based on the notes I gave, you were able to do. So based on those 4 questions, did you compare your problems with these problems and saying, okay, how did I do based on the rubric? Yeah? Okay. So here's my question. I'm sure that this gave you guys some clarity, going, that's what he really wanted. Got it. But I'm sure there's some other questions that you might have. Like, what do you mean by this? Do I need to do more of this? So what kind of questions do you guys have for me? Now that you've seen this, what I expect, and what you've handed in. What are some questions that you might have for me?
Do you want us to color code it like you did? Just curious.
Only if you want to. Not necessary. Because I find that the color coding makes things fit a little better, right? Makes things more understandable, but you don't have to. Because not everybody, I don't expect everybody to have an iPad and have like this, dramatic color pencil scheme. So no, it's not necessary. Next question. If you're at home, feel free to just unmute yourself and speak.
Let's say I wrote it's kind of like what you wrote, but for 1 and 2, but I added a little bit more.
More, I'm not going to frown on more. I usually frown on less. Okay? So the question was, if I did what you did, but I put a little more in it, it's okay, as long as it makes sense, right? Like if you were to go to step 2 and you said Toto is a cat, right? Wrong, totally wrong, right? Then I'd probably mark off for it.
I didn't know whether or not to write it put in A plus BI form. I got that, but I didn't know if I had to.
Correct. Makes sense. Makes sense. Yeah, I wouldn't frown upon that. If it's facts that is there, wouldn't frown upon it. It's usually when you take things out.
So essentially, if we write down our thought process and what we know, that's fine.
Yeah.
Okay.
Essentially, if Susie Q here doesn't know what's going on, right? I know, poor Susie Q. And you're like, hey, here's my lab work. I gotta go, but it should explain everything to you, right? So one of the things I was looking at that I was trying to point out was this problem right here, right? Which you guys didn't really do. I'm going to talk about this today anyways. So one of the things is, number 1, I need to pull out that square root of -1, right? So we got to put that fact there. And then over here, we're multiplying radicals, right? So we need to know the fact that when multiplying radicals, since we're multiplying radicals, what is the rule? Outside times outside, inside times inside, right? Great. Put that rule down. If we're adding radicals, what's the rule there? So we need like radicals. What the heck does it mean? Right? Index is the same, radicand is the same. Right? It's those little tiny facts that we need to know to take the next step, right? I don't need to know, next step is 6I plus 10I equals 16I. Like, I don't need that part. I just need what is the main rule that is necessary to do the next part. That's all.
For number 4, I know you would like for us to do the pairs, but would it be okay if I just do the extra and then do like root 9, root times root 5, and then separate it, just add extra steps for myself just so I can see it, or do you want us to?
You can if you want to. Yeah. Because, I mean, so the reason why I do it this way and teach it this way is only because I find that most students that I get aren't necessarily STEM based, right? And that's why I teach it this way. If it was STEM based, but you're saying you're doing extra, so that's the part that I'm okay with.
It was just easier for me to like act.
Yeah. Now, if you were to go from, let's say, square root of 45 to -1, square root of 9, square root of 5, then that's usually a STEM-based teaching, right? So for me, being an engineer major, that's the way I had to learn. There was no breaking it down. So the only reason I do it this way is because if we're not STEM-based, then I try to not teach it STEM-based. Because especially when the number gets bigger, it's a lot more difficult, right? That's the only thing. Okay. Any other questions? Anything to clarify at all?
Number 2.
Mm-hmm.
I understand what I did wrong, but so I like the first thing I did was I distributed the negative, which I don't think, like now that I saw what you did, so to figure out each of the square root.
And here's the reason why. What does the order of operation say? Because you're distributing will be multiplying, right? Does that come first, or does exponent come first? That's why you raise both of these to the second power first before you distribute the negative. And then subtracting towards the end. Adding, subtracting towards the end. Okay? That's why you have to double distribute first, then distribute the negative in.
Okay, so since these are going to be due at
Friday at 6 p.m.
are you going to be posting the answers so we can review them?
Okay, so this is what's going to happen. So remember I told you that I'm going to grade based on a test generator. I mean, not number generator, right? So let's say I pick number 5. When I pick number 5, what I'm going to do is most likely I will work out number 5, the two sides, and I'll send them out to you guys. Then I'll start grading number 5. Most likely that's what I would do, just so that you guys have it. You guys are knowing to expect what you're going to probably get, because if you're honest with yourself, you're like, all right, this one's going to be a 10 out of 10, I'm good. Now, if I give you a 4 out of 10, you'll be like, what the, right? What happened? So you'll look at the rubric and say, okay, he gave me a 4 here, a 2 here, a 1 here. I got this grade. Why did he think that? Is that fair? Okay. So when you look at it, look at the rubric and say, okay, I should get a 7. Okay. So if you get a 7, you're like, got it. Makes sense. I think the biggest one is going to be you think you got a 10, but when you go back in, I gave you a 1, and you're like, what happened? Most likely what will happen is that you thought you submitted, but you didn't submit anything.
Like no files?
Yeah, no file is submitted, right? It's because you'll try to do it on the phone, and the phone will say it's submitted, but actually on Canvas, it says you submitted nothing. So that type of stuff happens. So yes, you should definitely check. And with that being said, I'm so glad you brought that up. It's like I paid you money to ask this question. So with that being said, since we're doing a dry run, what I decided to do was I decided to look through lab work, and I said, you know what? I'm going to take a look at some of these and try to present some of the ones that might have some issues, right? And what the issues might be. So let's start with the first one. So I'm not singling anybody out because I have no idea whose this is. But there's a problem. What's the problem here? The clarity. It's hard to read, isn't it? If you can't read it, do you think I can read it? And I'm old. right? I can't read that. Although this one does look like that someone like broke into this person's room with a flashlight and say, I want to take pictures of this lab work. That's what it looks like, right? Like there's a little spot of light right there. All right, so let's go to the next one. This is not acceptable. No, you cannot just print out the lab work and say, I'm just going to do the work on there with my finger and the iPhone, right? Not acceptable. If you look at the directions, it has to be on a separate sheet of paper. And of course, there is no what we know. Enough said? Okay. What's wrong with this one? Know what we know. What do you notice of the problems? Wait a minute. What's the problem with the problems here? Does that look like our number one in our lab work? It's not even the right lab work. I don't know whose work it is. When was the last time we learned about pesos? Was that in the first day of notes? Pesos? And liters and gallons? No? Okay, I guess this is the total wrong lab work. Chemistry or MGF 1106, which is something that I taught times ago. All right. Same thing with this one here. Yes, someone submitted this for the lab work. Guys, do not submit to me the change of student data form. I don't do those. All right. Just so you guys know. All right. This isn't bad. Here is where my issue comes into play. Number one, the work from the other side is leaking through. Not very bad, but because of the leaking through and the jamming of those words all together, makes it harder for me to grade. All right. So this is not bad at all. Let me see. Oh. See this file right here? It says img_0467. It clearly tells me that you took a picture with your phone. Then you say, Google, convert this to PDF, and then it gives me this. It doesn't change the name, so it's obviously that is what happened. But in the first day, then I say something about, I don't really need to know that you have hairy legs, right? I don't need to know that you have a pretty sweater. I don't know what it is. And that you have a great idea for lead pencils of just buying those erasers and just jamming on top so you can have the eraser. I don't need to know that, right? But clearly this person just took their photos and just say convert it. Now there's a second problem with this one. They submitted like 4 files. Meaning each file was a single page. So if you have a problem with scanning multiple pages to one file, let me know. I'll help you. I don't have a problem helping you at all. Okay? So the problem is this, is that if you go to Lab Work 2 right now, on the top right-hand corner it's going to say Start Assignment. You click Start Assignment. It brings you to the bottom of the page. You click Choose File. Once you do that, you hit Submit Assignment, right? Goes back to the top. It shows you what you just submitted. And then that button that used to say Start Assignment now says what? But the button that used to say Start Assignment now says what? New Attempt. So when you submit a new attempt, guess what it does? It overrides the first attempt. When you click New Attempt again, it overrides the previous attempt, and so on. So her 4 pages that she sent to me, guess which one I'm going to be grading? Her 4th attempt, even if it's a single page. Does that make sense? So if you have a problem, I guess the tutorials did not help, but if you have a problem, let me know. I'll help you out. Okay? I don't have a problem helping you out. If I expect something, I expect that I should be able to help you out with that. Okay? All right. Oh, this is a good file. Do you guys see the difference between this page and this page? I finally figured out why people like CamScan. I just figured it out this weekend. 3 years later, I figured it out. So this is what this student did, just so you guys know. They used Cam Scanner. They fed in this piece, okay, which is already PDF. They apparently went on their either their computer and just started typing those things in. Number one, guys, I don't need these sheets anymore. I only want your work. Okay? Then what they did was they added onto it and then they imported photos from their phone. So they took pictures with their phone and imported it into Cam Scanner. So this is what Cam Scanner does. So in other words, when I'm looking at this regularly on my iPad, it should look something like this. Fair? The problem is that when I see your work, it looks something like that. That's what I see. The thing I like about this example, however, is this. Is that if you notice the difference of these two pages, is the fact that a photo, when converted to a PDF, doesn't convert it to an 8.5 by 11. So a picture is a lot larger than a PDF. This is going to be very hard to grade. And since this person took a photo, just so you guys know, if you like to use Cam Scanner, in Cam Scanner, when you bring the photo in, you can still crop it. This person decided not to crop it. And just so you guys understand this as well, this document is 14.2 megabytes, where, let me see, if we look at this Cam Scanner, it's 1.4 megabytes. That means it is, what, 10 times larger? If you look at this, there's 172 kilobytes. So what's the difference between 172 kilobytes versus 14.2 megabytes? You want it to be the same label, right? Okay. So if I was to change this to megabytes, this would be 0.172 megabytes. Or if I change it to kilobytes, this would be 14,200 kilobytes. A lot larger. Just so you guys understand, some of these large files, what will happen is that when I go to grade it, Canvas won't open it. If Canvas won't open it, it's the same thing as I can't read it. I can't give you anything. I can't grade it. So please understand that as well. Okay? All right, let's do a couple others. Now, this person right here, I love how you guys love to do things your way. I can't even fault you for it. But, so this person here takes a photo, crops it, then sends it to their, I'm going to say MacBook Pro or MacBook Air, and then takes those photos and puts it on Word document, stretch it out so it doesn't waste space on top or bottom. Awesome, great, great. Then to export it as a PDF. That's what they're doing. That seems like a lot of work. When you just go, done. Like why, but hey, what the heck do I know? I know nothing. This one, same thing. They just took photos and just smash it to Microsoft Word and then export it. A little dark, guys. Not enough light there. What's wrong with this one? Besides it doesn't have what we know. What else? Huh? What else is wrong with this? It's not in order. I don't have a problem with you starting your lab work this way, but guys, just recopy it in order. That's all. Okay? Because I want you guys to give me do a 1% better anyways. And this one here. See all the wasted space right here? On the bottom? Same idea here. This person here decided at 5:08 p.m. on Saturday to start taking screenshots of their iPad. And then taking those screenshots, put it around Word, and then convert it. And guys, if you guys have an iPad and you guys can do the work there, guess what? You can export those right out as a PDF. If you don't know how to do that, I don't mind helping with that either, okay? But this is not okay. Here's a good one that shows the leaking through from the other side as an issue. Everybody see that? Bad leak. Okay. This is what I mean by shadows. So any question on those? Does that help you guys a little bit? Again, I have no idea whose lab work those are. I'm just going through and saying, let me download these ones, okay? So no questions? We're good? Any other questions about lab work that you might have before Friday's lab work being due? We're good? Are we sure? Really, really sure? All right. Here we go then. All right, let's finish 1.4 and 1.5 and 1.6. Here we go. So the part that I didn't teach you guys was about adding and subtracting complex numbers. So with complex numbers, you might see it one of two ways. You might see it as this. Or you might see it as this. So you might see it in a plus bi form, or you might see it in radical form. So the question is, how do we do those? Well, in a plus bi form is a lot easier because if you think of i's as if they were so-called x's, it becomes a lot easier. So what's the first thing I got to do here? Do I have the FOIL? I just got to distribute the negative because I'm not multiplying the two binomials. So what I have to do is take this right here and just distribute this through. So I have 5 plus 4i. And when I distribute that in, I'm going to have minus 9 plus 8i. So I'm going to have negative 4 plus 12i. We're okay? Questions? None? Pretty easy? All right. So what would we do if it was in radical form? Awesome. So we want to first take out the square root of negative 1 first. And then break down the 75. And break down the 27. Now, if you can see it, Go for it. 25 and 3/4. So the index is a 2, so we're looking for pairs. So here we're going to have 5i square root of 3. Then you add. Yes? You want what? A pencil and something to write on?
Yeah, it's like a pencil and a piece of paper.
Sure. All good? Okay. Because I do have those things. And again, adding, subtracting radicals have to have the same radicals, right? So that means the radicand has to be the same, and the index has to be the same. What the heck is the radicand? Inside the house. What's inside the square root? Yes, that's the radicand. Okay. So the other thing we didn't hit on was multiplying a complex number. Same thing. You might see it in radical form. Like so. And yes, you might see it in a plus bi form, like this. So you might see it in this form. In this form, we would have to do what? The square term is attached to the parentheses, which means we have to write this out twice. And what do we do here? Double distribute. So we take the first term, multiply it into the second parentheses, take the second term, multiply into the second parentheses. I know, it's so not fair that I can just... You can't do that in your notebook? Just circle it, duplicate, slide? No. Dang it. Let's see if anybody catches on that. Minus 81. Ah. So it should be plus 81i squared. Let me do this really quick. So it should be plus 81i squared. And I squared is? Negative 1 times 81 is? Voila. So I'm going to have what? Negative 17 minus 144i. Make sense? We okay? What's the matter? What's the questions that we have? Anything? 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 No questions? That's it? Wow. Okay. How will we do this here? But this is multiplying. Oh, yeah. Well, how would we do this problem? Exactly the same thing we did before, right? So you're telling me that we're going to do...
Instead of adding 5i plus 3i,
timesing them. Yes. We're going to times them. We're going to do exactly the same thing, right? We're going to pull out the square root of negative 1. We're going to break down the radical, and we're going to times them. But multiplying radicals is outside times outside, inside times inside. So the example I always give is that you can only multiply if you're both outside the house. You can only multiply if you're both inside the house. You can't multiply if one of you guys are inside the house, one of you guys are outside the house, right? And please don't try that at home. So here, some people are going to get the joke, some people are not. It's okay. So here I'm going to have 15 because of 5 times 3. I times I gives me I squared. And square root of 3 times square root of 3 gives me what? Just 3. Which is going to give me a negative 45. Come on, box. Give me a box. Box. There you go. Are we okay? Good? What's the matter?
I was a little confused on the threes. Like, you multiply them together.
Not the I. No, not the I. I know the I.
The square root of 3. Like,
She's talking about
I'm
this.
confused.
How does this times this gives you this? Is that what you're asking?
Yes.
Okay.
Yes, sorry. Cancel it.
Well, think of it this way. So another way of rewriting this right here, if I multiply them, would be, let's use a different ink here. So square root of 3 times square root of 3 is the same as saying square root of 3 squared. What's a, or better yet, the square root and the squared are also opposite operations, which cancels each other out, which that's why we're only left with 3. Okay? Yes? As in this one.
Yeah. Instead of separating it into the two binomials, can you do a squared plus 2ab plus b squared?
I want to punch you in the face. Well, you could. Here's my issue, though. My issue with that is that now you're remembering something new. Does that make sense? Yeah. Because if it was 8 minus 9i times 7 plus 2i, you'll have to do exactly that anyways, or aka FOIL. So why even remember that?
It's just in there.
You know what I'm saying? Like that's where my issue is. But I'm glad you brought it up because at least I know if I see that on the lab work, I know where it's coming from.
So do you want me to avoid doing that?
I would, because it's gonna happen what? Maybe 0.5% at a time?
Yeah, that's what I was asking.
Yeah, it's just like what? Like if I was your high school teacher, I would rather that you hammered down the AC method and completing the square rather than remembering a squared plus 2ab plus b squared, right? Like just to me. Yes?
Okay, when you went from a minus 9i to, what happened between that one and the next line?
From here to here?
No, the one above it.
Oh, from here to here.
Yes.
Okay. So what I did was I have to take this and multiply this through here. So I'm just doing it a little long-handedly. And then, yeah, I got to multiply this through here, so that's why I wrote it that way. Yep. Yep. Any other questions? Awesomeness. All right. Let's talk about quadratic equations. Anybody remember what a quadratic equation is? You're only saying yes because she's getting you. Oh, yeah. So quadratic equation looks something like this. Ax squared plus bx plus c equals 0. So one of the things I keep on saying in class, especially for the ones that have had me before, you guys are going to hear me say it a lot in this class as well. If I see a square term and an equal sign, what should I be thinking of? And the answer is quadratic equations. Which means that once I see a square term and an equal sign, I'm going to try to bring everything to one side so that I have a non-zero side and a 0 side. Okay? And the non-zero side, well, to solve for this, there's 3 different methods to solve for this. First one is called factoring. If it's 2 terms, we use difference of 2 squares. If it's 3 terms, we would use the AC method. And if it's 4 terms, we will use, anybody? Factor by grouping. FBG. So when we got to this section of intermediate algebra, I hammered my students about this. Like, I threatened them. Like, if you guys don't get this down, there's a chance that you're going to fail this class. In fact, if you don't get this down, you're probably going to fail exam 3 for sure. Okay? So I kind of hammered it away. So most of the students I've had, not all of them, most of them, are going to remember exactly how to do the AC method. So if you're not good with the AC method or factoring in these 3 ways, please get it down. All right? Yes?
What is for the, what's that word? Like, this word over there.
Where?
Like over that line.
Over here or over here?
Yeah, there.
Quadratic equations. QUA, DRA, TIC. Equations. So, before I get into that, so that is one method of solving for this, is use factoring. The second method is the quadratic formula. Does anybody remember the quadratic formula? Go ahead. X equals. Man, there's no rhythm behind that one. Yeah, that's the quadratic formula. You guys ready for the news? We hardly ever use it. Yes. We'll be using the parts though. So this semester we're going to talk about the negative b over 2a. In pre-calc you guys would talk about the b squared minus 4ac. But we're never going to talk about the quadratic formula. Yes?
So like, stopping after like, let's say plus, is it like 8 or is it like 0?
This is a 0.
And then like those other words like after like the like.
2 terms, like this. This is the difference of 2 squares. This is the AC method. And this is the factor by grouping. And the third method is completing the square. This we will be using. In fact, there's going to be some problems we're going to use it twice. Yay! That does not look like a face of enthusiasm there. Give me some enthusiasm. All right, so which one of these methods do you feel like you're struggle with? Completing a square? Okay, so let's do that. So let's go ahead and bring this method right down here, and let's put an example here. Let's do. Whoa. All right. There you go. Let's try that example. So I do love completing the square. There's only one thing that holds completing the square up that becomes kind of an issue. What's that? Now, that was the first issue that completing the square has. Fair enough. Fair enough. That's a good generalization. The first step of it is the fact that A has to equal to 1. Right? And if it's not a nice problem, we're going to end up with fractions. And we all love fractions, right? She's like, almost a yes. But our A is equal to 4, right? How do I make a 4 1? Do I just divide this by 4? Everything. Divide this by 4, and this by 4, right? Everything by 4. And that's why we get fractions. What is a step 2? So we found out that C is cheating on the family, so we're going to kick him out. Don't want him anymore, right? One strike rule. Find you cheating, you're out. So we're going to move the C to the other side. So I'm going to say move old C to other side. Well, what happens when you kick the old C out? You get yourself a new one, right? You're going to find yourself a new C. Okay. What's the equation for C? Very good. Thank you. Yes?
And I'm like, what's the thing? Like I'm just my whole this with yeah.
This right here?
Yeah.
This says move old C to other side. Okay, so what is b here? Negative 3/4. Divided by 2. What's negative 3/4 divided by 2? Let's zoom in here. What's negative 3/4 divided by 2? Clearly makes your head hurt. What's negative 3/4 divided by 2? So what are we doing here? Aren't we dividing fractions? How do we divide fractions? Keep, change, flip, right? So we keep the negative 3/4. We change the division to multiplication, and then we flip the 1/2. I mean, flip the 2, which becomes 1/2. So the top is going to be negative 3, and the bottom is going to be 8. And yes, if you would just multiply these two, you will get that. That is very true. Because that's what's going to end up in the denominator anyways. Right? Because when you flip the 2, it becomes 1/2. All right, what is negative 3/8 squared going to be? Very good. Wow, you guys are so fast. Yes, 9/64, since negative 3 squared is 9, 8 squared is 64. Okay? So we got to add that to both sides. Awesome. So let's take that, duplicate, add 9/64 here, which means I have to add it to the other side as well. Boom. Step 4. So what we're going to do is we're going to factor that left side. While adding or subtracting the right side. So before I continue on, before I do step 4, is there anything in step 1, 2, 3 that we have questions about? Is everything pretty clear? Standard form, A equals 1, kick the OC away, find a new C. Are we okay with all those 3 steps? Yes? No questions there? Okay. So, step 4 seems hard because we have to factor this nonsense right here, right? With fractions and stuff. Well, guess what, guys? If you do the work, the factoring is already done. This one right here, everybody see where this is coming from? Yes? Everybody got this? See, you guys all know where this is coming from. Don't worry, I'm not spoon feeding you any baby food. But your factoring is done. So if you do the work, the factoring is already done for you. If you do the work, the factoring is already done for you. If you do the work, the factoring is already done for you. Did I mention? If you do the work, the factoring is already done for you?
Simply, like, step 3 is where you're going to get your
Factors. Correct. And on the right side, I got to add and subtract fractions. What do I need in order to add or subtract fractions? You need a common denominator. What's my common denominator? 4 times what gives me 64? 16. Right? So what's that going to give me? Is that right? Oh. Light bulb just go. Ding. Are we okay so far? So far, so good?
And then
Well, good news is that I'm going to upload this for you. So it's already going to be there, so you can copy it off of there too. Is that okay? All right. Oh, it's going to be right on your Canvas homepage. So for example, here in week 1, if you missed the first day of class, it's going to post it there as live lecture. Okay? And so in this case, it's going to be under week 2, and wherever I finish, you'll see it done too. But this is a Monday, Wednesday class, so you'll see it here as your Tuesday, Thursday at 1:30. Okay? I have an answer.
So how does -1 times 16 equal -7 plus 9? Got it.
I'm so glad that you answered your own question. Yes?
The answer is -7/16.
Yep. Well, the answer is not that. When you added these two, it became -7/64. Right? Because -1 times 16 is -16 plus 9 gives you -7/64. Whenever you're solving, what are you solving for? Aren't you solving for x? So it's not your answer because it doesn't say x equals yet. So there's one more step. So the last step is to solve using the square root property. So if I'm solving for x, I got to get rid of this squared, right? How do I get rid of a squared? What's the opposite operation of squared? Huh? Square root. Agreed. So if I take the square root of this side, I have to take the square root of the other side. But what does the square root property mean? Why do I need to know about the square root property? What the square root property is saying is, anytime we take the square root of something, we have to include what? A plus and minus. We have to include the plus and minus. That's what the square root property is saying. Every time you take the square root, you have to include the plus and minus. It's a must. So now that I've taken the square root, I got x minus 3/8 is equal to plus and minus. Let's see if you guys catch on to this one. So x is now going to equal to Does that make sense? So the question is, what is it about completing the square that's difficult? It is a lot of steps. So, if there's a lot of steps, what's the only way to make those steps easier? Practicing, right? It's just practicing. What's the matter? What did I do?
Oh no, I'm just,
Did I make a mistake?
no, I just on the not like before you put the answer.
Hi, I got here?
Yeah.
Okay. Okay. So when I took the square root here, right, I'm taking the square root of the top. So the square root of the top is, whoa, running off, is the square root of -1 and square root of 7. So you know where that came from. Square root of 64 is just 8. Okay? So that's where this came from. So you're good there. Okay. So you're saying, how do I go from here to here?
Yeah, like that.
So I have to add. It's okay. So, ladies and gentlemen, one of the things I have always said to my past students is this. If you have ever experienced where you would bring your notebook in and you're like, Professor, I got a question, and you start talking, and you're like, oh, never mind, got the answer, right? So every time you saw the professor, you're like, got the answer. Just like you two just demonstrated, right? You talk it through and got it. So when you guys are stuck on your homework at night, what I need you guys to do is, maybe what you guys want to do is maybe use the back of the calculator, find a picture of me, put it here, and when we have a question, you just prop me up and start talking to me. And you're like, oh, never mind, got the answer, got it. Just don't let your boyfriends or girlfriends or parents find out, because that may be kind of weird. Why do you have a picture of a professor sitting right there? And why are you talking to it? But hey, if it answers your question, why not, right? All right, any other questions? How are we with the AC method? We're not ready to rock it yet? No? Come on. All right. Something. Guys, yeah, that should work. All right, let's do that. And just so you guys understand something, this original problem right here, 4x squared minus 3x plus 1, you couldn't use the AC method for this. Just so you guys understand. Basically, after the first step of the AC method, you would get stuck. You won't be able to find the two numbers. And that's the reason why you will have to then go to completing the squares or the quadratic formula. Okay? However, this problem here that I'm about to go through, the AC method will work because you'll go past step 1. Hence, you can get to step 2 and step 3. Okay? So, as you guys can see here, A is equal to 3, B is equal to negative 2, and C is equal to negative 5. Everybody agree with that? Okay? So, step 1. So step 1 is A times C. So in this case, it'll be 3 times negative 5, which gives me a negative 15. Everybody agree with that? We're good? B is going to equal to negative 2. We agree with that. Okay? So this is still not done with step 1, because step 1, all you're looking for is this. What you're looking for in step 1 is two numbers that multiply together to give me negative 15, but yet added together, the same two numbers added together would give me negative 2. And those two numbers are? Negative 5 and 3. The screen in front of me just went black. So I'm like, did it interrupt anybody else? All right, so those are my two numbers. That is step 1. Step 2 is that I'm going to use those two numbers, the negative 5 and 3, and split the middle term. Okay, let me try this, guys. Sorry. Interruption. All right, I'm going to keep on going. So what I'm doing here is this, guys. I'm keeping the first term and the last term. I'm taking this middle term right here and splitting it. Weird things are happening, guys. So there it is. So you guys see the -5 in action, the +3 in action. All right? Okay so far? And step 3, now that the left side is 4 terms, we're going to do factor by grouping. So if you were to try to do this on the first problem we did, you'll get stuck here. You will not be able to find these two numbers to happen. That's when you know, okay, I got to go to completing the squares. Or so here, factor by grouping, I split this down in the middle. I'm going to find the GCF of the first group. So here my GCF is going to be x, leaving me with a 3x minus 5. GCF of this group here, there's no GCF, so I'm going to do a 1, leaving me with 3x minus 5. Then I'm going to look at the GCF of the whole thing, which is 3x minus 5, left with x plus 1, and that's going to equal to 0. And then I'm going to set each factor equal to 0. And there we go.
The same answer. I just set mine up differently. I don't know how to explain it.
No, it's fine.
Oh, okay.
Yeah.
I don't know why I just do it like that.
It's okay. It's the same. It's the same thing. So the only difference, what she's talking about, is that the -5 and 3 is just swapped. So she did +3 and -5, right? Anytime I have a choice, I will always write the -1 first, because it doesn't. Then it reminds me that I don't have to necessarily pull a negative out of the second group. That's all. Okay. Any other questions? We're okay so far? We're good. So please get these 3 steps down. Okay? All right, the next thing I wanted to talk about is radical equations and equations with rational exponents. I'm really wondering why this is still off. Yay! There you are. Ah, sees yous. All right. So let's say, for example, I do this. So this is a radical equation. What should I do first? Huh? Move the x to the other side? And why am I moving the x to the other side? To get what by itself? I'm trying to isolate the radical. Okay? Because I know the opposite operation of the radical, that's why I want to isolate it. Okay? So there's going to be a lot of problems that we get into where we have to be able to isolate what we know the opposite operation of. Okay? In this case, since we don't know the opposite operation of a radical, come on. There you go. So that's what we want to isolate. And the opposite operation of a square root is squared. Gotta square this side, gotta square this side. Are we okay so far? We're good? No questions about this? We're good? Okay. So I see a square term and an equal sign, right? So what should I be thinking of? Awesome. That means I got to bring everything to one side. So 0 is going to equal to x squared plus 10x plus 9. Do they both work? Are these my answers? No. ¿Por qué? You have to check them. So I'm not going to tell you to check everything. However, I will tell you what is necessary to check. At any point in time with a radical equation, if the index or the root is even, you need to check. Okay? Since this is a square root problem, you do have to check it. And what you're going to find out is that the negative 9 will not work. However, the negative 1 does work. So you will have to reject the negative 9. So yes, you will have to check. On your lab work, I should probably see the work for the check. On the exam, I don't really care. If you want to just do it in your head, that's certainly fine. And saying, okay, negative 9 times 4, negative 36 plus 40, positive 4, square root of that is 2. 2 minus a negative 9 is plus 9, so that's 11. That doesn't equal 7. I'm okay with that. If you do that in your exam. On the lab work, I should probably see. From here to here? Now here's my question. Why is it that when I did this step 1, I already knew the factors, but that didn't happen up top? That didn't happen here. Because my A and C was negative 5 and 3. That is not what I got here. Why is those two different? Why did it work down there but it didn't work up here? I'm so confused. No, I still did this down there. And I didn't do step 2 and step 3. A is not equal to 1 here. However, A is equal to 1 here. When A is equal to 1, you can take the shortcut. That's the only time it will work for the shortcut. If A is not equal to 1, you cannot take the shortcut. You actually have to finish the AC method. Okay? So that is something I've taught in the past, so that's why I'm bringing that up right now. So that's why here I can just do step 1 and voila. Right? 9 and 1, 9 and 1. Cool? All right. Oh, now I gotta draw this fast. Pressure, pressure, under pressure. Who sings that song? Are you wondering why I'm drawing a sun and grass and okay? Oh, this is math. This is so math. Not good drawing, but this is math. All right. So, am I correct by saying that the grass is a division between light and dark? Ask anybody that's been buried 6 feet under; they're going to tell you it's pretty dark down there. Is that true? Okay. I'm not sure how you're going to ask. You can now. Thank you. So, yes, this cute picture is talking about math. All right? So that's what this is talking about. Are we okay there? So, whenever I bring this up, there's some exponent rules that we learned, right? We learned rules like a to the n times a to the m. What do we do with the powers there? A to the n plus m, right? And if it's dividing, then we subtract. How about this? A to the m raised to the m. What do we do that when I raise a power to a power? We multiply them. A to the n times m, right? So there's a bunch of those different rules, right? Okay, great. Here's my next question. If I said the square root of x, how do I write that as a rational exponent? What over what? Because the power on the x is 1. The root is a 2, isn't it? Because there's no number in the wedge, that means it's a 2. Does that make sense? So if I say the square root of x, it'll be x raised to the 1/2. Are we okay? All right. So the reason why I talk about radical equation and rational exponents is because if I was to take this problem right here, would you agree with me that I could rewrite this with rational exponents? Would you agree that I can rewrite this as raised to the 1/2 power? Same thing, right? Awesome. So if I was given this problem right here, would I still get rid of the x first so I can isolate the thing being raised to the 1/2 power? Yeah, because I need to know what the opposite operation is. So yes, I would still do So question is, what is the opposite operation of something raised to the 1/2? Huh? Oh, because with the square root, we said we are supposed to square it, right? So we should just square both sides again. Now, what's the relationship between 1/2 and 2? They're reciprocals of each other, aren't they? So in other words, with rational exponents, the opposite operation is the reciprocal power. And you're like, why though? Because what am I doing here? Am I not taking a power, raising it to a power? And when I raise the power to a power, what do I do with the power? You multiply them, right? What's 1/2 times 2? Right? Right? 2 halves is equal to 1, right? Half of 2 is equal to 1, right? So if you take any fraction multiplied by the reciprocal, it's always going to equal to 1. 3/5, 5/3, 15 over 15, 1. Right? That's why it works. So the opposite operation of any rational exponent is always going to be its reciprocal. Fair? The only downside of these problems, though, is knowing the fact of when I should check, when I should not check. Because it's confusing, right? If you were to focus on the original problem and say, okay, is that denominator even? Yes, I should check it. Now, if you don't mind doing the work and you don't want to remember that fact, it's okay. Just check everything in that case. You're always safe then. If you check everything, it's always safe, okay? So this is still exact. So everything else here, exactly the same as this right here. Right? The rest of it is exactly the same. Nothing changed. The only thing that changed was what power it is and how do we find the opposite operation. Pretty easy? Questions? None. No questions whatsoever. Are we sure?
I have a question about your son.
Go for it.
So, past classes have had down below how-to examples of the same exact question, but we don't have.
Correct. I shut them down.
We're not allowed to have it.
Correct. Yes? A minute ago. So the question was, some of the classes, some of the professors will have MLM, and the bottom will have, help me solve this, view an example, blah, 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 blah. I X-nayed those because, so before AI even came out, I already X-nayed those. Because I want one of two things. One, for you to refer back to your notes. Two, I want you guys to consult with me. And just so you guys understand, because this is what happens during class a lot. Guys, your notebook, I know, turns this way as you guys are like writing notes and you turn the page. Today, just a new update, these pages actually turn the other way too so you can review your notes. Just so you guys know. It's a new technology, man. All right? Whole new era. But that's why I kind of turned those off, is because I want you to consult with me with it. All right? Other than that, ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Thursday with all of your questions about lab work. Later, Gators.